The centerpiece of the MagForce nanocancer therapy is the nanoparticle, consisting of iron oxide. The particle is covered by a patented coating which ensures a good stability and division of the iron oxide particles in the tumor tissue. It additionally supports the process by which the particles are absorbed into the cancer cells. The small size of the particle is decisive for the therapy. The diameter measures some 20 nanometers and is thus 500 times smaller than a red blood cell. 1 milliliter of the particle solution contains nearly 17 trillion single nanoparticles. This high density makes efficient treatment possible. At the beginning of the therapy, the nanoparticles are injected directly into the tumor. The tumor in this particular case is a glioblastoma, a malignant brain tumor characterized by aggressively growing cells. On the microscopic level, the healthy cells can be seen on the left and the tumor cells on the right. After being injected, the nanoparticles spread out in the spaces between the tumor cells. The patient now enters the therapy device in which an alternating magnetic field is produced which is of no danger to humans. This field affects a 100,000 times alternation of the magnetic poles within the particles per second, creating warmth which is precisely regulated from outside. The warmth forces the particles into the spaces between the tumor cells, which makes it easier for them to be absorbed into the cell. This application is repeated and the thermal effect increases visibly. The particles begin to oscillate, causing the cancer cells to die either from active self-destruction or from swelling until they literally burst. Tumor growth is stopped and the destroyed cells as well as the nanoparticles are discharged by the body in a natural process. As a rule, the 1-hour minimal invasive treatment is repeated 6 times. However, the particles are only injected once, thus making the therapy especially gentle on the patient.